In this part, we will be looking at waking up the device from a low power mode. We continue from one of our previous projects where the device goes into sleep mode after 10 seconds. Now, we would configure an external interrupt to wake up the device from sleep mode. And we will configure another interrupt to send the device back to sleep mode. We will make use of the buttons S1 and S2 already present on the EK board. We also note from the datasheet that these buttons are connected to the interrupt 10 and interrupt 11. So we look at the program that we have already written that puts our device to sleep after 10 seconds. In order to add the interrupts, we will go to the FSP configuration tab and we add a new stack. Under input, we can find the external IRQ. The first interrupt request, we will name it IRQ_10. And we will make the channel 10 as well. Once we have made the channel 10, you can see that the IRQ10 has already been processed as pin P005. We also have to define what happens when the interrupt is activated. We will try to put a function name in the callback column. We name it IRQ10_callback. This is the name of the function that will be called when this interrupt occurs. In the same way, we create the configuration for the second interrupt. The S2 button is connected to the interrupt 11 pin. So we name it IRQ11, and when we change the channel to 11, you will notice the pin is automatically assigned. We will name the callback function IRQ11_callback. Once we have defined the stacks for our interrupts, we will generate the project content. Now we will edit the hull entry.c file. We will first make a loop which would be running in the normal operating state. For this case, we just write a simple LED blinking function. We will now configure our interrupts. Under the Developer Assistance tab, we can find the functions associated with the interrupt stack. We will first define the interrupt. We carry on the callback function definition and paste it here. This is the definition for IRQ10. We do the same for the IRQ11. So now we have two callback functions defined. We would like to use the button S1 to exit from the sleep mode. Therefore, we would like to close the sleep mode when we have this interrupt. When the second interrupt S2 is pressed, we would like to make a delay of 4 seconds and then enter the sleep mode. Once we have defined the callback functions, we will now need to open the interrupt channels and enable them in the main function. You can find the required functions in the Developer Assistance menu. First, we need to open IRQ10, so we drag it here. Second, we need to enable that. In the same way, we have to open the IRQ11 and then enable it. We can now build this program. There seems to be 3 warnings here, so let's resolve them. The interrupt function is defined to have an argument. Since we do not use this argument, we will be calling the FSP parameter not used macro to prevent the compiler from producing the warning. We have another warning where the sleep function has not been declared, so we add a declaration statement. The program is now ready to be built again. As the program has compiled without any warning, we can now debug and upload it to our microcontroller board. Once the program has uploaded, we will unplug the board and then reconnect for demo. We plug in the EK board first and the device starts operating in its normal mode. The normal mode operates for about 10 seconds. After 10 seconds, the device enters sleep mode and the current is reduced to about half. To wake up the device, we simply have to press 1. When we press S1 button, we can see that the current has increased back and also the LED is blinking, which means it's running on its normal mode. In order to enter the sleep mode again, we need to press the button S2, which calls on the second interrupt and after 4 seconds goes into sleep mode. To bring the device back to its normal mode, we just have to press S1 again. Note that the sleep current will vary for different models of microcontrollers. And that was a very short demo for waking up the MCU using interrupts.